Hello there, welcome back to this video, 2C-4, we're solving exponential equations. So, we are going to go ahead and jump in, and just a reminder, you have to be able to change from exponential form to logarithmic form today and be able to undo logarithms and exponents with their inverses in solving this equation. In the last video, we looked at solving exponential equations with exponential property of equality. Check that video out for more information about how to use that. We are going to focus in this lesson about solving an exponential equation by going to logarithmic form or vice versa. So just remember, if you are working with exponential base, the logarithmic base is the same, and they are inverses. They will undo each other. So we can use that to cancel either of those out. And then since they're inverses, inputs and outputs switch. My input of an x is going to end up being my output for a logarithm, and my output a ends up being the input called an argument for a logarithm. So just be comfortable switching between those two forms. Now, how do we go ahead and solve an exponential equation of this form, where we have an a value times an exponential base raised to some power cx plus d, maybe plus a constant, and let's say it is equal to some output f. Well, we're going to go ahead and use inverse operations, and generally what I like to do is, again, I use this process called SADMEP. It's Aunt Sally reversed. Undo addition, subtraction, undo multiplication, division, then you'll undo the exponent or anything in parentheses, okay? So they say here, number one, use inverse operations to write the equation in exponential form. Number two, rewrite the equation in logarithmic form. So what they say here, step one, they want to go ahead and isolate this exponential expression, and then we'll go ahead and rewrite it in logarithmic form. Then what we'll do is continue solving the variable, and again, since the domain is exponential, since we're dealing with exponential function, the domain's all real values. There's no extraneous solutions unless we get an imaginary solution. Let's look at an example. Okay. Man, what do I want to do with this? I'm gonna skip that practice problem. We'll come back to it. It's important, but it's not the focus of our lesson. So, example 1. The function q is given by q of x equals 2 times 5 to the power of 3x minus 8. Find all values of x for which q of x equals 6. Okay, I'm going to take my function, 2 times 5 to the power of 3x minus 8, and I'm going to set it equal to 6. I want to go ahead and, again, look at SADMEP if you need this. If you're unsure about what do I do first, do I undo multiplication, do I undo the subtraction of 8, SADMEP says we undo addition, subtraction first. So I'm going to add 8 to both sides, plus 8. These cancel, and now I have 2 times 5 to the power of 3x equals 14. Double check this. You cannot multiply the 2 times the 5. So some people will often be like, oh, just multiply that, it becomes 10. No, this 5 has an exponent to it. Okay, it's protected by this exponent. So you're going to undo that 2. So here's where we undo multiplication or division if we had it. So I'll divide both sides by 2, and I now get 5 to the power of 3x equals 7. Here's where you can rewrite this in logarithmic form in order to solve this, or you can use a log base. I'll take log base 5 of both sides in order to cancel this. So I now have 3x is equal to log base 5 of 7. Now I'm almost to x. I just got to get rid of this 3. So I'm going to undo, again, I repeat here. So now I undo the multiplication of 3 with division. And then here is our answer. Log base 5 of 7. Okay, and we're going to divide by 3. Now you can rewrite this. Another way to see this answer would be 1/3 of log base 5 of 7. Okay, and there you go. There's your answer. You would only have to express this as a decimal value or an integer 1. If you could simplify this and reduce, you can't. And then or you had a calculator and then you could evaluate that with a calculator. So here we're fine. This is most likely going to be a multiple choice question. I guess it could be a free response question too on 4. So let's look at another example. The function f is given by f of x equals 1/5 4 to the power of x plus 6 plus 1. Find all values for which f of x equals 3. I'm going to go ahead again. I'll set f, which is 1/5 4 to the power of x plus 6 plus 1 is equal to 3. So again, undo addition subtraction first. SADMET will say that. So then I get 1/5 times 4 to the power of x plus 6 is equal to 2. And now I'm going to undo this division of 5, or this fraction. If you get confused by fractions, just remember you undo them by multiplying by the reciprocal. So in this case, it's going to be 5 over 1, which is just 5. So I'm multiplying by 5 on both sides. That will cancel that fraction. And I now have 4 to the power of x plus 6 is equal to 10. Okay, now exponential equation you can rewrite as a logarithm or use log base 4 in order to cancel. And so what we get is x plus 6 is equal to log base 4 of 10. Now pretty easy to answer here. I'm just going to go ahead and subtract 6 on both sides. So here is our solution. X is equal to log base 4 of 10 minus 6. There you go. There is your solution. Okay. Practice problem. Go ahead. I want you to pause me. Please solve for where z of x is equal to 10. Okay. Here's what I went ahead and did. I set the function z equal to 10, and then we solved. So I'm going to subtract 6 on both sides first. Then we went ahead and multiplied by 2 on both sides. So multiply by 2. And we end up getting 3 to the power of x over 2 is equal to 8. And then we went ahead and took log base 3 of both sides, or rewrote it as logarithmic form. And so we get x over 2 is equal to log base 3 of 8, and then I multiplied both sides by 2. Multiply this whole thing by 2. So you get 2 log base 3 of 8. This could potentially be an answer, but this is such a common property, I would expect them to make this log base 3 of 8 squared, which is 64. Okay, so this is what I got, log base 3 of 64. Did you get it? All right. Okay. Let's go ahead and look at this next example. This one's slightly different. They say the function w is given by w of x is equal to e to the power of 2x minus 5e. Solve for w of x is equal to 2e for values of x in the domain of w. So again, what I'm going to do here is I'm going to take my function e to the power of 2x minus 5e and set that equal to 2e. So the first thing I want to do is I want to isolate my exponential function. I know this has an e, but it's not e raised to a power, so I can't factor this. But I do have 2 e's over here. So what I can do is I can combine like terms. I'm going to add 5 e to both sides, 5e to both sides. And what this gives me is it gives me e to the power of 2x equals 7e. Okay, now that I have that, I can go ahead and isolate my 2 to the power of x. That's what I want, right? Well, how do I undo base e? With a natural log. Okay, so, or again, you can rewrite this in exponential form, natural log. So these cancel, and we get 2x is equal to the natural log of 7e. Okay? Again, a couple of ways you could progress by this. My natural inclination would be to go ahead and divide by 2, the natural log of 7e over 2. But there is a way to simplify since I do have an e in here. I can split this argument. You see how they're multiplying? Well, I can use the product property. I have the natural log of 7 plus the natural log of e, which the natural log of e is just 1. So natural log of 7 plus 1 over 2. Okay? And if they were really getting freaky, they might go ahead and just divide each of these terms by 2. So you have 1/2. Well, before I do that, some of you guys will freak out. Natural log of 7 over 2 plus 1/2 is the same thing as 1/2 ln 7 plus 1/2. I don't know how far down the scale they will go or make you go, but all of these are equivalent answers, okay? You may be fine like this based upon the FRQ. If it's multiple choice, then you might have to search for one of these forms to be equivalent. But they're all equivalent, and you should feel comfortable moving to all of these, okay? All right, couple of practice problems here for you. Go ahead, please pause me. Try this practice problem. They want you to solve for v of x is equal to 4e. Go ahead and do it. Okay, for this example, we went ahead, combined like terms, move that 2e over, and then I divided by 6. So divide each side by 6, and you get 1/3 e is equal to e to the x. Use a natural logarithm on each side in order to cancel out that base e. And then we get natural log of 1/3 e is your answer. You can go ahead and manipulate this. A couple things you can do. You can use product property to separate them. So natural log of 1/3 plus the natural log of e. This is likely because this is an identity, definition-based identity. Natural log of e, it's the same base. So that is just 1. We simplify that to 1. And then depending upon what you could see, note 1/3. 1/3 is 3 to the power of -1. So you could even see this as natural log of 3 to the -1 plus 1, which is negative natural log of 3 plus 1. And who knows, they might get wild and go 1 minus natural log of 3. All of these are equivalent. All of these are equivalent. So just be comfortable, okay, going between these. The FRQ will tell you what form they want it in, so you'll have to make it into that form. But just know, multiple choice, you could have to find any of these, right? All of these are equivalent to each other. Okay, last practice problem. Please pause, try this example. Okay, here is the solution. You add 3e to both sides, and then you're going to end up dividing by 5 to give you e to the power of x plus 4 is equal to 2e. Again, I'll take a natural log of each side, and I get x plus 4 is equal to natural log of 2e. I'll add the 4, and then again, because this has an e in it, you're most likely going to have to separate this using the product property, right? Since we're multiplying, that's adding 2 logarithms to the same base. And natural log of e, this is 1. So you get 1 minus 4, which gives you our final answer, natural log of 2 minus 3. Okay, hopefully in this video you were able to use inverse operations in order to solve exponential equations, and in the previous video you could solve exponential equations using the property of equality. Give this video a thumbs up, like, subscribe for more awesome math videos. I'll see you guys next time.